Okay. Okay. So today's topic of the meeting is unit testing. Oh, sorry. Unit testing and assignment 2. So as always, start out with some announcements, and then I'm going to talk about unit testing. Well, I'm going to sort of talk about assignment 2 and unit testing at the same time. And so hopefully this will get you started and, well, more than just started. It'll help you figure out how to do assignment 2 in a principled manner. Okay, some announcements. So quiz 1 and assignment 1 are being marked or have been marked by the TAs. When all of them are done, I will publish the results. You should have received an email yesterday, and there's also an announcement on OnQ saying that assignment 2 has been moved. The due date has been moved to the 4th or 5th. Is that the 5th? That's the 5th, right? Friday's the 5th, I think. I think that's right. And quiz 2, yeah, that's right, it's the 5th. Quiz 2 has been moved 1 week. So it was supposed to be on Thursday the 4th. It's now on Thursday the 11th. And that's so that you're not working on the assignment and the quiz at the same time. Okay, so those are the announcements I have. Let's see, anybody have any questions before I get started? Friday's the 5th, yeah, okay, thanks.
Yeah, Professor Ma, it's just regarding the assignment too. I think so a lot of us have difficulty in understanding the assignment. So will it be possible if you can just give a quick brief through of it?
Yeah, that's what I'm going to do in today's talk.
Oh, okay. I just thought you were reviewing the slides, and I just saw week 6. So
no, not outside yet. I'm stopping here to see if anybody has any questions about the announcements.
Okay, sure.
Okay. Anybody else? Anybody? All right. So there was a Jupyter notebook released yesterday morning, I think. Sometime yesterday. Might have been Monday. I don't remember anymore. It's about unit testing. So the textbook, there's like basically a paragraph on testing. And I don't know why they bothered to include it because it's not very useful. So what I'm going to show you is a principled way to do unit testing in Python. Any testing that you've done so far has probably been ad hoc. That is, so that is basically you've probably written a customized program to test your code, and you looked at the output of the program, and then you decided yes or no, what you've done seems to be correct, or more precisely, yes or no, you have or have not found some mistakes in your code. And so I'm actually going to do that right now. Okay, so here's assignment 2. Yeah, if you got an email saying quiz 2 is due, it was changed, so I just changed quiz 2 today. The email went out last night about the change. And the quiz and the assignment date. So the quiz and assignment dates were also changed last night, but OnQ doesn't always pick up on them immediately. Assignment 2. So hopefully you've all seen assignment 2. If you haven't seen assignment 2, I don't really have time to go over to introduce it to you. So what I need to do is I need to start idle. So in Mac, I've got this terminal open. I'm in my 121 course directory. I have another actually I'm in the assignment directory. Here we go. So I've got my Mac set up so that in my documents folder, I've got a course folder, and then in that course folder, I have an assignment folder. So I'm currently in that assignment folder, and I'm going to start idle from here. If you're in Windows, you just start idle from the start menu, and then you have to open up your file using the file browser. If you're on a Mac, you can start it this way. So I've now got my idle editor window open, and I want to open up, well, let's open up Life 1, because that's where you have to start in this assignment. Okay, so when you open up Life 1, you see some documentation here, which would be, you probably want to read that if you haven't read it already. You see that there's a function already defined for you called make cells, right? And so make cells says that it returns a list filled with a specified value, right? Should actually say a little bit more here. Well, the documentation for the parameters tells you here, right? So n is the number of elements in the return list, and val, that's the element that appears repeatedly in the list, right? So you can, if you were writing this yourself, you probably would have done this in one of two ways. You would have opened up idle, and from the command, you would have opened up idle the shell. So you would have opened up the shell, and you would have played around trying to figure out how to make a list. Or you would have written the function, and then you probably would have tried to call the function. So I'm going to do it that way. So I've written the function already. I'm now going to make another little test program. So I'm going to open up a new file, right? Life1 is a module, right? So it's another Python file that contains a bunch of functions. So if I want to use a function from Life1 inside of another Python program, I have to import the module. Right? So that's what the import statements are for. Right? And so now that I've imported Life1, I'm allowed to use a function in Life1. So for example, I can use make cells, right? And so I can now call the Life1 function make cells. And let's make 5 cells. So a list of 5 cells, and their value will all be true. Right? And I can call it that way. And I think most of you probably would have printed it out. Right? So you do something like this cells. Right? Then you're going to save it. So I'm going to save this as test Life1. You can call it whatever you want, of course. Right? And then I'm going to run it. Right? So how do you run it? So you can run it lots of ways. You can run it from the command line. Right? So back here on the command line, I can just do Python 3 for me. I have to type Python 3 because I have many versions of Python installed on this thing. I can run that. Right? And you can see it prints out true, 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 true. Right? So it makes a list of length 5, and all the values are true. If you're in idle, you can press F5, or you can go run module, and that will open up an idle shell and run it for you. Right? So that works too. So that looks good. Seems to work. You can play around with this a little bit more, right? So for example, if I made them all false, save, right? Run again. So press F5. I should get a list of length 5 with all values are false. So this seems to be working okay. Okay, I just want to quickly go back to Teams to see if there's any questions. Oh, there are.
Professor, I actually have a question.
Go for it.
So you were saying that you said there that most of us would have gone just put out the output line as print cells.
Yeah.
Are you suggesting there was another way to do that, or was just kind of testing in the idle shell the alternate way that you were suggesting?
So the easiest way to determine whether or not this is working is to look at the result, right?
Right.
So the easiest way to look at the result is to print it. The problem with printing it is that someone has to look at it, right? So for our purposes right now, this makes lots of sense, right? I'm testing a single function that I've just written or that someone has given me, and I want to know if it works, or I want to know how does it work? Like, how should I use this function, right? So it makes sense to experiment with it. And to see if it actually works, typically, if you're only testing a single thing, the easiest way is just to look at the output. The problem becomes when you have to test many things. So eventually this Life1 module is going to have 5 or 6 or 7 functions in it. And you don't want to have to look at the output every time you test something to see if it's passed or to see if it's working correctly, right? Which is what I'm going to show you shortly when we talk about using a unit test framework to do this.
So do we have to use, because like what I've been doing so far is just using the test programs, like the files that were in the zip.
Yep.
So that just, we don't have to create our own tests. You're just showing the principles.
You don't have to. Okay. So here's the trap that most students get into. The instructor releases some test programs, but the test programs are never, they're never really, well, not never. Often the little example programs that you're given for an assignment, they're not very, they don't test your program rigorously, right? So that is, they don't look at all the special little corner cases that that you might run into when someone else uses your code that you've written, right? So for example, the test programs, they basically only run one example for each function, right? And so I gave them to you to help you, actually, to help you test your programs and to debug, right? So is there one for make cells? I don't think there is one for make cells, is there? There's a print cells one.
Print cells,
right?
yes.
Yeah, so
and that's actually
right?
great that you bring that up, because this actually kind of segues into a larger point that I had, which was as I was creating my functions and linking them up together to produce the desired result of basically step-by-step building up the game of life by making cells, printing cells, evolving cells, or rather, sorry, before evolving cells, defining the neighborhood. It wasn't clear to me how exactly the program was supposed to, like the end result of the program was supposed to function. Like I was wondering, in terms of the actual design or look, in terms of what cells are alive and what cells are not alive at the start, like I wanted to know, how do I create the initial condition? Is the initial condition based off of command line arguments that they're input by the user, or is it an initial state that is defined by me randomly? Like I'm inserting a random choice function that randomly assigns true or false, alive or dead values at the start of the game of life, or am I programming it so it only has one initial setup?
No, so this assignment, you're basically making a module that anybody else can use to create a functioning game of life, right? So you're this is the other trap students get into. The other trap that students get into is that many students think that the goal is to produce a functioning program, and that's not true, right? As a software developer, often you're not making a finished program, right? You're making something that someone else can use, right? In this case, you're making these modules Life 1 and Life 2 that anybody else can use after the fact. Right, and so it's not necessarily your responsibility to make a running program, but you can easily make a running program if you wanted to, right? So, for example, you were asking about do I make a random thing of cells and then run it, or so on and so forth. So where did that go? File, open. Tesla. Oh wait, that's the one I have already. Sorry, I don't have a. Where is the example life 1? So example life 1, right, is an example program that uses the life 1 module to run a game of life. Right. We make a bunch of cells. Right. This part up here. So I make a bunch of cells that are all false. This this loop here sets the cells to that. So false, 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 true, true, false, false, true, true, so on and so on and so on, right? Prints the cells and then evolves them for 30 generations, right? So that runs a game of life for 30 generations, printing the cells each time.
Okay, so that's part of my question, which was the expectation is that in this case you have S being defined as this string of dashes and hashes. Is that the expectation of how these programs are going to run? Is that we are going to accept inputs
like that are... The assignment doesn't ask you to make a running game of life. The assignment simply asks you to implement these functions. Right? Nowhere in the assignment does it say make a running game of life that starts out with these initial conditions, or does it blah, 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 blah. Right? The assignment just says write these functions, and then when you're done the functions, you can see what they can do by running these example programs. Right?
Okay, because what I was struggling with like neighborhoods, for example, was the point between neighborhoods and evolve. Like I was trying to get the to define the neighborhood based off of like a true or a false value based off of like a random
So I'm
randomly
going to do the
input?
neighborhood function in about 10 minutes.
Okay.
Okay. Okay, anybody else? Any other questions? Sorry, I only have the one monitor today, so I have to keep on opening Teams and taking a look at the conversation. Oh, and then the mouse works backwards on Mac compared to Windows. So, okay, they're currently being marked. We eventually put all one. Yeah, you want to from the other? No. Life one should only contain the functions that you're asked for in the assignment. Right. Life one is the module that contains the functions related to the game of life, the one-dimensional game of life. Life two is the one you'd have all the functions related to the two-dimensional game of life. Right. So there's probably, depending on how you decompose the problem, there's probably going to be somewhere between 5 and 7 or 8 functions in each module. Okay. All right.
Professor Ma, I have
okay.
a question.
Sure.
Sorry to interrupt. So I know that we can import another file into we can import a file into another file, right? And we can access those functions from the previous file which we imported. Is there a possibility that we can use the variables from the imported files functions?
Not unless they're global. You have to mark them as being global.
Okay, so within the function itself, like, do we have to mark them as global within the function, or how are we supposed to?
You shouldn't be using any global variables in this assignment. Like, there's no reason to make a global in this assignment.
Okay.
Right. The assignment literally is make some functions. There's no reason to create a global variable of any sort.
Okay. Yeah.
Yeah. Okay. What am I doing here? Life one. Right. Okay. So on with the assignment. Oh, testing. Right. That's what I was talking about. Where's my? Here we go. Okay. So writing a small program and manually examining the output of the program is fine if you're doing if you're testing a very small number of things, right? So if you want to know how some function works, you typically want to experiment with it and see exactly how it works, right? As soon as you start to test several things, this has a lot of disadvantages, right? So number one, someone has to look at the output, right? And it's possible that to test one function, there might be a lot of output. So you might have many test cases that you're testing this function for, right? And now there's a lot of output when you run your test. So now you have to sit there and carefully read all of the output to see if it matches what you think you should be getting. There's other problems too when you start to test a large amount of code, and that is often you'll want to exclude certain tests because you know the things that you're testing already work, or you know that they're not going to work. So you want to exclude them. If you write a custom program to do this, it becomes really awkward to start picking tests to not run and picking tests to run. And finally, the other problem is there's no good way to automate this process, right? Because basically there's a person or persons that has to interpret the output. So if you want to do automated testing, which is very common these days in software development, writing a small program that someone has to read is not going to work. And so what's done is something called unit testing. And unit testing basically involves testing what are called units of code. So what unit means depends on many factors. It depends on the language you're using. It depends on exactly what it is you're trying to test, and so on and so on and so forth. Right. So for our purposes in this course, a unit is just a Python function. Right. So basically what I want to do is I want to write tests for every function that we're going to write. And so to do this, there's lots of different testing frameworks. So a framework is software that someone else has written that other people can use to build a working program. So a testing framework is software that someone has written that lets other programs write testing programs. Okay, so there's lots of these unit test frameworks. Sorry, excuse me. The standard one that comes with Python is called I forget what it's called now. It's called unit test. The problem with unit test is you need to know object-oriented Python, which we don't do in CISC101 or CISC121. So it's not really suitable for our purposes. PyTest is a different and very popular unit testing framework that doesn't rely on object-oriented pipeline. And so PyTest is something that all of you can easily understand how to use. The problem with PyTest is that it's not part of the standard library, so you have to install it, right? The instructions for installing it are right here, right? So in a command, so on a Mac, you would just open up a terminal like this, and then you would literally type pip3. So pip3 is Python's package manager. It lets you install and remove packages from the, it lets you, it's a program that lets you install and remove and maintain and update packages, Python packages. So all you do is type that, press enter. Mine's going to say that it's already here, right? So you get a bunch of stuff basically saying PyTest is already installed, right? If you're on Windows, it's the same thing. As long as you're, as long as you've installed Python 3 somewhere, it should have come with pip3, and you type the exact same thing in Windows. So it'll be pip3 install minus big U PyTest, and that will install PyTest. You don't have to do it now. You can do it whenever you've got some time. And only if you want to use PyTest, right? So if after today's meeting, if you decide that this is going to be something that you might want to do, go ahead and install PyTest and to use it to test your programs. Okay, so the remainder of this lecture is all going to be done using idle, right? So I'm going to close. That thing and go back to the assignment.
Professor, can I just ask something about what you were saying there about object-oriented programming?
Sure.
So I don't know if this is a short question or a long question. If it's a long question, you can just disregard it. But I'm just curious to know why the type of programming we're doing right now is not considered object-oriented or object-oriented programming.
You're not making things called classes, and classes are the things that you make objects. So you've been using objects in the course, right? So every time you use int or float or bool or list, those are all objects, in fact, right? All of those types are actually created from classes. Right, and so what we don't teach you how to do is how to make a class in this course, right? So when you make a class, you're basically making a user-defined type.
Oh, okay.
And we don't do that in this course, right? This course isn't about object-oriented programming. The problem with unit test is that the unit test module is that you have to make a class to make a unit test. And so I'd spend basically a whole lecture explaining what all this stuff is, even though you're not going to use it at all.
Right. Okay.
So that's why I've decided to go with PyTest.
Okay, yeah, I was just confused. I was like, how come we're not doing object-oriented programming if we're using objects all the time?
Object-oriented,
that makes sense. Yeah, it has to do with the classes.
Yeah, how do you make classes? How do you make objects? How do the classes interact with other classes? And so on and so forth.
Okay.
Okay, that's CISC124, but you do it in a different language. Okay, where's here? Okay, assignment 2. So the assignment 2 says you should then make this function called print cells that basically prints the cells in a nice way, right? So let's do print cells. So it's a function, right? I want to put it in the life1 module. So because it's a function, it begins with def. You have to call it print cells for the purposes of this assignment. And I think I give you the signature. So I give you the entire, yes, I do, right? So it should look like print cells, right? So your input argument will be this thing called cells, right? And if you read the assignment tells you that this function should take a list of cells and it should print out the contents of the list in a nice way. So that is, it should use the pound sign or the hashtag sign for any cell that's true, and it should use the hyphen for any cell that's false, right? Okay, and so what you have to, the thought process here is that, well, I've got a list of cells. I need to do something for each element in the list, right? And so as soon as you arrive at that conclusion, you should know right away that you probably want something that looks like a loop, right? Because I need to do something for every element in the list. So for each, so you're gonna use a for loop, probably. You could use a while loop. For loop's a little easier in this case. You have your choice of two different types of loops, right? So you can use a loop that uses a counter, right, and range, or you can use the for each loop. The for each loop works here because you just want to do something once for each element in the list. So I can write something like for each cell C in the list, right? So that's just saying for every element named C in the list named cells, I want to do something, right? So if the cell C is true, I want to print out a hashtag, right? So if C is true, right, I want to print hashtag. I'm going to leave it like that. It's not right, but I'm going to leave it like that for now, right? If C is not true, right, so if it's false, right, I want to print out the hyphen, right? And then the assignment says, after you've printed out all the cells, you should print a new line, right? So after I've printed out all the cells, in other words, after the for loop, right, print out a new line. So that's just print with nothing in it. So that'll go to the next line. And that's it. You're done. So save that, right? And now how do I test this? Well, I go back to here, right? And now I call life1 print cells. Right, save that, press F5, and what do we get? We get hyphen, 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 hyphen. So 5 hyphens. So false, 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 false. Now they're all supposed to be on the same line, right? So now you go, oh, they're supposed to be on the same line. So I go back here and you say, well, how do I print something and not go to the next line? Well, you specified the end character, right? So end equals quote, quote, nothing in between, right? There's no space here, right? Means don't go to the next line. Right. And, oh, sorry, this is a Mac, so I have to do command. Command G. There we go. Good. Save that, come back to here, press F5, and there you go. Hyphen, 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 hyphen. Now, what you should realize is that when you test it with just all falses, you're only testing this part of the if statement, right? You want to also test this part of the if statement. So you want to make at least one of these cells true, right? So let's make the middle one true, right? And then print out the cells again, right? And so now when I run it, I should get 5 hyphens, and then on the next line I should get 2 hyphens, a hashtag, and a hyphen. And that's what I get, right? So it seems to be working. Okay, any questions? Yeah, it's being recorded.
Professor, I have 2 questions here for this.
Fire away.
So I'll start with the second one because it's probably the more simple of the 2. So I'm just curious to know why with the calling of functions, why you don't need to actually have a print line. So like for example, when I access this test file in the terminal, you're doing it currently in the idle shell.
Yep. Yep.
But if I'm accessing in a terminal, if I don't have a print line, does it automatically just print the caller?
Python test life1. Oh, hang on, what did I do? Did I screw something up? Invalid syntax. That's not invalid syntax.
Oh, end is equal to? Did you do a...
It's not complaining about the space, is it?
It has to be a space, isn't it?
Oh, what's going on? Oh, hang on. Python 3, sorry. I told you I have many versions of Python on here, so there we go.
Okay.
Yeah, so that was running Python 2. Yeah, so Python, yeah, it works. It does the exact same thing that the shell does.
Okay, so that's interesting to me because I've always assumed that you had to have the print line to return the result.
To return a result.
Or to return the output of the function.
No. You have to, you have to print something, right? But the function is printing something.
Oh, the function already defines print.
Yeah.
So as long as
Prints
you're
out
calling
the
the function.
Yes.
Okay.
Yeah.
Okay, so the other way you could do this is you could have just assigned that if C is equal to true, then you change that cell to hashtag.
No, you don't want to change the cell.
Then,
That's not what no. That's not what the assignment says to do, though, right? Print cells, prints a list of cells, right? It doesn't say modify the list, right? It says print the cell, print the elements of the cell, print the cells, so that you get something that looks like that.
Okay, because the way I structured it in mine was I actually did, which I guess leads into my second question, because what you have here is you have your single for loop in which you're iterating through each element of the list.
Yeah.
And then you're printing, if it meets this condition, you're printing a hash. If it meets the other, you're printing a dash. What I did is I first iterated through the range. And then within that, I was iterating like the range of elements. And then within that, I was iterating through the list. And then I was changing, if the value was true, I was changing it to a hashtag. If it was false, I was changing it to a dash.
Okay. But that's not what it says to do, right?
Okay.
That's not what it says to do. So.
But isn't it the same result?
You don't get the same result because as soon as someone tries to use your list cells for something else, it's going to barf.
So what would they be using it for? Like otherwise, like would they be changing the value in terms of like whether it's a Boolean or something else?
The lists that you're using in this assignment, they should always be all Booleans, right? That's how the cells are defined as, right? So it says, where to go? Somewhere in here it says that the cells are always Booleans, right? It's just trues and falses. That's all they are, right? When you print them, it might be it's a lot nicer to see something like this, especially if you want some sort of visual representation, like the game of life, than looking at something like that, right? So your representation is always a list of all trues and falses, right? What that gets printed as, well, that depends on what print cells does.
All right, so you're saying that the reason I'm doing the way I'm doing it of actually changing the list elements from Booleans to the string of either a hash or a dash, it just introduces a degree of perhaps error, or it introduces the potential for error because it's now changing your elements from being Booleans to something else.
So what it's doing, so the textbook will tell you that if you have a function that modifies the elements of a list, that function is said to have a side effect, right? So the side effect of your function is that it's modifying elements of the list. Someone using the print cells method, right, especially when they read what print cells is supposed to do, right? Print cell says it prints a list of cells, right? They're not expecting the function to have any side effects, right?
Oh, okay. So this is what I'm doing is making a side effect, and I'm not keeping it in Booleans.
Introducing an unnecessary side effect in this case, yes.
Okay. Yeah, it seems superficially to be the same result, but you're saying it's very different because I'm having a side effect of changing the Boolean. Okay, that makes sense now.
Do you have a second question?
That was kind of my second question of the way I had done it, and that kind of, I guess, followed from how you weren't using print lines in the actual caller.
Yeah.
Okay, that makes sense.
Okay. Now, I have to hurry a bit because otherwise we're going to run out of time. Okay, so the neighborhood function. So the neighborhood function is supposed to return the neighborhood around the cell. So what that means is if you've got a cell somewhere in the middle of a list, it should give you back the list of length 5, having the 2 elements on the left and the 2 elements on the right, and the cell itself, right? So you want the 2 cells on the left and right of the cell that you're interested in. But if you're right up against an edge, right? So if you're right up against the left-hand edge, there are no cells to the left, right? So you should only get the cell and the 2 cells to the right. Similarly, if you're right up against the right-hand edge, there are no neighboring cells to the right. So you should only get the cell and the 2 cells to the left, right? if you stop and think about this for a little while, right, you'll realize that you can do this all with a slice, right? So in other words, you can pick the using indexes which cells you want, given the index to the cell that you're interested in. Sorry, where neighborhood, here, right? So if I'm interested in the neighborhood around cell 0, right, I should get back a list of length 3. It includes the cell itself at cell 0 and the 2 to the right, right? The neighborhood at cell 6, which is at the end of the list, right? I should get back the 2 cells to the left and then the last element of the list, right? And so I want this, so I want a function that does that. Right? What am I calling it? Neighborhood, right? So I want that and B, right? And so I'm going to do this ignoring the boundaries of the cells of the list, right? So cells is my list. That's the cell I'm interested in. I want the 2 cells to the left plus the cell plus the 2 cells to the right, right? So I can just return cells index -2 to index +2, right? So that looks pretty easy, right? Oh, sorry, not round brackets, sorry, square brackets. Right, and so, sorry, Command S, there we go. So that solves the problem using a slice. You can use a loop if you want to. I think this is easier. But now you go ahead and test it, right? So, sorry, I want my tester, please. Oh yeah, I've got every window but the tester. Here. Okay, so once again, if I'm on the command line, right, I can just do something like n for neighborhood equals like1 neighborhood cells. I have to be a little careful here because my list of cells is only in like 5, so I have to, there's only one that I can do to make this work. So there's my neighborhood around the middle cell, right? I can now do like 1. Cell then. Try that. Okay. And so why don't I do it? I'm going to print out the cells instead. So like print. And there we go. Okay. So I'm getting false, false, true, false, right? I should be getting this, right? I should be getting false, false, true, false, false, right? Because I'm looking for the neighborhood around the middle element. And so I want the 2 to the left and 2 to the right, right? And so you see, well, there's a problem. I'm missing the extra 1 to the right, right? And that's because the slice does not include the last element, right? So I need to do index +3. So back here, run it again. And now it works, right? So that's the neighborhood around the middle cell, right? Now the problem that you run into here is that it doesn't correctly deal with what if I want the neighborhood around this cell, because there aren't 2 cells to the left of it, right? So if I want the neighborhood around this cell, I should get back the false because there's only 1 cell to the left. I should get the cell itself, and I should get the 2 to the right. So I have to deal with that. But what I want to do instead is I want to use PyTest to test this thing. So I'm going to import PyTest, right? And now, instead of writing some Python code that prints something out or does something like that, I'm going to write an actual test. So a test in PyTest is a function. So I need a function. The function name either begins with test or it has to end with test. And so I typically start them with test. So I'm going to call it test underscore. And then typically what you do is you name it, you give the name of the function that you're testing. So I'm testing the function neighborhood. And I'm going to test in the middle of a group of cells. So typically your tests end up having very, very long names, because you try to put in some details about what the test is actually doing. And now the way this test works is, so I have to call this function neighborhood, right? To call the function neighborhood, I need some cells. So I have to set up what's called a test case, right? So my test case for this function is I need some cells and I need an index, right? So I need to define what are called the inputs to the function that I'm going to call. Right, up here, the way I did it was I just made some cells. So I'm just going to do that again. Sorry. Command V. There we go. So I'm going to make some cells, right? I'll just leave them as all false. That's fine, right? I'm going to pick an index. So I'm going to use the index 2. So I want the middle of this particular list of cells, right? And then I call the function that I want to test, right? So I want to call neighborhood in the life1 module, right? It returns a list of cells, so I need that return value, right? So the neighborhood is equal to life1 cells, right? So once again, pick some input values for the function that you want to test. Call the function that you want to test, right? Define what and then the next thing is you have to decide, well, what was the answer that I was expecting from this function, right? So in other words, what is the neighborhood around cell 2, given that all the cells were false, right? So I know what that is, right? So the expected answer is just false, 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 and false, right? Expected result, right? And so now, what does the rest of the test look like? So the rest of the test looks like this. Assert n equals the expected. So what we're doing here is, that's the answer I got back from the function. That's what I expect the answer to be. I want to check, is the answer I got back from the function equal to the expected answer, right? And this, what is assert? Assert, I think it's what is assert in Python? I don't know if it's a function or if it's an operator. I'm going to assume it's a function. So assert in Python, if this value here is true, then assert does nothing. If that value is false, assert raises what's called an assertion error, right? So in other words, you get an exception and your program stops. The way PyTest works is it handles this exception and then it prints out a nice error message for you explaining what went wrong. So let me just save this and run it. Now running a PyTest thing from idle is awkward. So I have to do this one with the command line. And so it's PyTest, name of the test, so test life1. And so here, that's the output from PyTest, right? So PyTest tells you it's running this test program, the test file test life1 py. That's the output from the test, right? So it says one test passed in 0.01 seconds, right? The 100% means it ran every test that it found in the file. So you can put as many of these tests as you want into this file. So for example, I can now test the left-hand side. So I'm just going to copy that test. Sorry, I keep on hitting command instead of control. Okay, so now I'm going to test the left edge. Right? So I'm going to do the same thing. I'm going to make some cells, but now the index that I'm going to test is index 0. So it's the first cell, right? The neighborhood for this thing here only includes the cell itself, right? Plus the 2 cells to the right, right? So in other words, this neighborhood is not length 5 because there aren't 2 neighbors to the left, right? And then I'm going to assert the same thing, right? The neighborhood returned by that function should match my expected value. So if you save that and run it again, it's going to barf, right? And now you see that 1 failed, 1 passed. So this is the test that passed. This is the test that's failing. And up here, it's trying to tell you why it failed, right? And so it even tells you what's going on. Right contains 3 more items, right? So this thing here, right, has 3 more items than the thing on the left, right? The thing on the left is n, right? And so that's my neighborhood function. So my neighborhood function is not working, but I already knew that because I'm not accounting for the fact that that index is negative, right? And so now you've got a test that fails, right? And you've got some information about why it failed. So now you can go back and fix up your function. So that thing there, that's the left edge of the slice, right? That thing there, that's the right edge of the slice plus 1, right? What I have to be careful of is I can't let this thing go negative, right? And I can't let this thing be bigger than the length of the list, right? So can't be negative, right? Can't be bigger than the length of the list. Okay, so I'm going to change this then. So that's the left edge of my slice, right? So I'm going to call that left index. I'm going to put some spaces because I find it hard to read otherwise. Right index. And now I just have to define the left and right index. Right, so what's the left index? Well, the left index before was index minus 2, right? But I can't let that value go negative, right? And if it goes negative, I want to set the value to 0, right? So if left index less than 0 equals 0, right? Right index is similar, right? It's the index plus 3, right? And I can't let that value become bigger than the length of the list, right? So, well, that's easy. If right index is greater than the length of the list, right? Then I want the right index to be equal to the length of the list, right? And so that's one way you could make sure that this works. There's a more concise way to write this. So once I make that change, I've now got this test already written, so I can just go back and run the test. And voila, it works, right? And now I can add the test for the right-hand side. Right? So I'm going to test the neighborhood on the right-hand side of the list. Right, so now my index is, what's my index? It's the length of cells minus 1, right? That way, if I change this to some other number other than 5, I don't have to change index. And so what's my expected answer? Well, it's the same thing, it's all falses, right? Because my list of cells is all false, right? But it's length 3, right? So that's the cell itself, and these are the 2 cells to the left, right? Save. Run the test, 3 pass, and now I'm good to go, right? This is probably going to work no matter what, right? There is another test case you might consider, right? You might consider testing if the index is 1, right? So I'm just going to edit this test case. You shouldn't do this. You should write another test case, but I'm just going to edit it. And now, if the index is 1, there's 1 cell to the left, right? There's the cell itself, and there's 2 cells to the right. So should be that. Test is so that's tell us that test is written. Oh, sorry. Run again, and away you go. Right? And so now your neighborhood function's done. It's tested. You've got a record of your tests, right? You don't have to read the output because PyTest spits out this great big colored stuff. Right, you can't miss it now, right? Something went wrong. It's all red, right? So you can't miss it now. It's a lot easier to use. You've got a permanent record of your test. If you had other tools available to you, you could run the test automatically whenever you did something. So for example, if you're using GitHub or something like that, there is a way to set it up so that when you check in this code to GitHub, GitHub automatically runs the test for you. Right, and that's what would happen when you're in a professional environment. Right, every night before you go home, you would check in your code, and your code will automatically run it. Your code will automatically be run against a bunch of unit tests. Right, you come back the next morning, hopefully all the tests have passed. Right. Some places won't let you check in code if your code does not pass the existing unit tests. So that's another thing you could do. Right. Okay.
Professor, there's also the case, just the last case, which was the second last cell.
Yeah, you test that too, sure. You're gonna quickly realize that there are more test cases than you can feasibly test. So right. You have to, don't go crazy writing like 1,000 tests for these things, right?
But anyway. I have a question here actually about what the just this neighborhood function that you came up with.
Yeah.
So my definitions of the possible slices were slightly different. So I actually included within my, I don't know if it's appropriate to call it input validation, but within my function for neighborhood, I had all of the cases which were individual slices for zero, the zeroth element, the first element, the middle elements, and then the second last and last elements. So
you had special cases for each of the...
Yes.
Yeah, you do it that way. Yeah,
okay, because the way you're doing it is obviously like much more compact, concise than mine is. My way is just I have several if statements and then an else statement for the middles.
Yeah.
I'm just wondering if that's acceptable or if that's just like kind of clunky.
CISC121 is acceptable. As you gain more experience as a programmer, or if you were to go work in a professional environment, you should probably you'd want to solve it in a way similar to this. This isn't the best way to do it either. There's a more concise way of doing this. So I'll just show you the more concise way of doing this. Left index equals. So here the left index is either this value or it's 0, right? So if you think about it, what you're really saying is it's the max of 0 and index -2. Right? The right index is either index +3 or it's the length of cells, right? Whichever is smaller. There, and that's your, and now that's your complete function. So that's the way, that's probably the way most professional Python programmers would write it, after they've thought about it for several minutes.
Right.
It doesn't necessarily come to you right away. As long as I'm here, the assignment tells you to raise a value error if index is less than 0. So you really should be doing if index is less than 0, raise. And you should include an error message here. But yeah. So that either this, so this plus this would be your complete function, or this plus this would be your complete function. You should probably prefer to do it this way, because when you go to do the two-dimensional case, you really don't want to specify all the special cases.
Sorry, you're saying that I should do it the second way that you have?
Yeah, either way is fine. You can do it either way, but you don't want to enumerate all the special cases for the two-dimensional case.
Okay, yeah.
There's too many of them.
So yeah, the way that I did it was sort of like the noobish beginner programmer way.
Yeah, but you are a noobish beginner programmer, so...
Exactly. My only other question about this, because you're defining the index in regards of 5. like a length 5? Is that specifically because your caller is?
You mean for the assignment purposes?
In the functions you have right now, you're defining the length of in the neighborhood function, you're defining the index in relation to a list of length 5 because the caller was calling on a length 5?
You mean here?
Yes.
Oh, no, here I just picked whatever number I wanted. I mean, so...
because I'm just trying to see where the left...
Yeah, so the first test, you need a list of at least length 5. Because,
okay, because I was looking at the index you have, and your left index is index -2 and right index is index +3. I was wondering if that was because your caller is calling in 5?
It's because that's the way the game of life is, the one-dimensional game of life is defined. Right, the one-dimensional game of life is to neighborhood. But you can have variations of the game of life where it uses a bigger or smaller neighborhood. So if you use a smaller neighborhood, the one-dimensional game of life is not interesting. But you can use bigger neighborhoods if you want to, right?
Okay. It's
just for the purpose of the assignment, it's a 2 neighborhood.
Oh, I see. Okay, now I see how the function is actually working. Left index is equal to index -2, and so that's removing based off of where the index is, where you're starting from.
Yeah, you want to go 2 to the left. Right? Yeah, you want to go 2 to the left. Yeah.
And then index +3.
You want to start 2 to the left, and you want to end 2 to the right. The way the slice works, though, is that index isn't included. So you have to add 1 more.
Okay, so your return there, you're using your cells based off of, you're defining what left index and right index are.
Yeah.
And that is for any index anywhere in there. It could be at the right of the list, like the end of the list or the beginning. Okay, I'll have to look at it for just a second more because obviously I did the noobish programmer way, and this is like a very elegant, more advanced way.
It's a lot more code. It's harder to debug, and it's harder to maintain.
Yes.
Yeah. But I mean, if it works, I wouldn't ask the TAs to deduct any marks.
I'm just curious to know, like in the class right now, like if anyone's willing to raise their hand of how many people think they would have been the noobish program like me, or if they would have actually arrived at the more advanced function, like what you've put down, or not advanced, but the more elegant function that you put down.
It's I don't know if it's more elegant. Yeah. It's I mean, it all comes from experience, right?
Right.
Okay, so I've already kept you for an hour. Does anybody have any questions? It is recorded. I will post the video probably after. I have 124 at 4. 3 to 4. So I'll probably post it after I finish 124. What keyboard or kind of switch do you have? Keyboard. So I use a Metadot, a DAS keyboard. It's I think. I don't remember if these are blues or browns. And I actually have 2 of them here. So, but yeah, it is a mechanical keyboard because you can probably hear me clicking away. Yeah, they are cherry reds, but I think they're brown. Or I don't remember if they're blues or browns. The switch type. Any other questions about the assignment or the testing?
Yeah, I had a question. Oh,
go for it.
Wait, no, Alex.
Oh, hang on. I think it's Alex.
Yeah.
Oh wait, so it's somebody else actually. Is it Aniket? Sorry,
yeah.
I don't know who it is. Okay, so anybody go.
Yeah, Alex.
Okay, yeah. So for the evolve function, in the example code you gave, it says the very last line, it calls print cell, and then you send C. But when I use mine, it doesn't change because C wasn't in the function. So I put evolve C when I sent it to print cells. I put the evolve C so that it changes the cells.
Right.
Is that okay?
No. You mean this example here?
Yeah, no, but in that last line, you're sending C, but I don't know how to actually change it in the function because when I send it back, it doesn't change C.
Evolve should change C.
Yeah, but it changes it in the function. But when I send it back,
No. It should change. See, it shouldn't change. So it sounds like you're making a copy of the list and then changing the copy.
Mm-hmm.
So here, let me quickly show you something. So I'm going to write a incorrect version of evolve. Okay. So if I do not. Okay, so there's my not correct version of evolve. Right. If I someday I should learn how to use a Mac properly. Anyway, okay. So I'm gonna do it up here. So if I now do live one evolve cells print cells and then whoops, Command V. Oh, that didn't work. I guess I'll just type it. Okay. So I'm going to print out my cells, I'm going to evolve them, then I'm going to print them again, right?
Mm-hmm.
Okay, so there are my cells before evolve, right? False, false, true, false, false. After evolve, it's true, false, false, right? Because I negate the first cell, right? So false becomes true. So that changes cells.
Okay.
Right? Yeah, if you make an assignment to an element of cells, that will change the list cells.
Okay,
So,
that answers my question.
Good.
Thank you.
You're welcome. Anybody else?
Yeah, I had a question about the assignment. So when we're like submitting it, like, do you expect us to have like our unit? Do you expect us to have unit tests in it?
No. Don't submit the unit test.
Okay. So, and another thing, should we like document our code like the same way that you did for the first?
Yes, I believe the assignment does ask you to do that, and I didn't show you how to do it today. Where does it say? Each function in your module should be documented using the convention. The easiest way to do this, and by the time you're done doing this, you're going to hate me, but it's something you need to learn because it's very tedious to do. So the easiest way to do this is just to copy mine. And then for print cells here. Oh, again, sorry, I'm pressing the wrong keys, Command V. Okay, and then change what I wrote here, right? So print, prints list cells using for true. And so for live cells and minus for dead cells, a new line printed after printing the cells. Come down here, nuke that. So your parameter name is cells. It's a list. Technically, it's a list of bool, but list is fine. The list of cells doesn't return anything, so get rid of this. This one does not raise an exception, so you get rid of this. And there's your documented print cells. Unfortunately, Python has no standard documentation format, so there's no way in idle to insert default documentation. Why there's no standard documentation format in Python, I don't know. Because Python came after Java, and Java has one. Anyway, any other questions? Okay, so we're a little bit over time. If you have any questions, please come to office hours tomorrow, mine, or ask the TAs. I've heard the TAs have been quite busy with questions, so that's good. There is a forum for assignment 2 that you can post clarification questions there too if you want. And I'll try to make sure to keep up looking at the forum. Otherwise, I have to go and get ready for CISC124. Any other questions? Okay, thanks. I hope that was useful. Yeah, that's it for today.